Good morning. I am Devasena. In this lecture, we are going to discuss about H parameters or hybrid parameters. This topic is present in the subject circuit analysis under the unit two-port networks. Let us start discussing about H parameters or hybrid parameters. H parameters are also called hybrid parameters. These parameters are very useful in constructing models for transistors. The transistor parameters cannot be calculated by either short circuit admittance parameter or open circuit impedance parameter measurement. Thus, we have V1 is equal to function of I1 V2. That is, input voltage is the function of input current and output voltage. Similarly, I2 is the function of I1 and V2. That is, output current is the function of input current and output voltage. These parameters are obtained by expressing voltage at the input port and the current at the output port in terms of current at the input port and voltage at the output port. Thus, the current I1 and voltage V2 are considered to be independent variables, while voltage V1 and current I2 are considered to be dependent variables. In equation form, above relations can be written as V1 is equal to H11 I1 plus H12 V2. Consider this as equation 1. I2 is equal to H21 I1 plus H22 V2. Consider this as equation 2. In matrix form, the above relation can be written as matrix of V1 I2 that is equal to matrix of H11, H12, H21, H22 into matrix of I1, V2. Let V2 is equal to 0, that is port 2 is considered to be short circuited. The individual H parameters can be defined as follows. From equation 1, we have V1 is equal to H11 I1 because the term H12 V2 is considered to be 0. Therefore, H11 is equal to V1 by I1 at V2 is equal to 0. The unit of H11 is ohms. The parameter H11 is called short circuit input impedance because H11 is the ratio of input voltage V1 to input current I1 at output voltage short circuited. That is why it is called as short circuit input impedance. From equation 2, we have I2 is equal to H21 I1 because the parameter H22 V2 is considered to be 0. Therefore, H21 is equal to I2 by I1 at V2 is equal to 0. The parameter H21 is called short circuit forward current gain. It is unitless quantity because H21 is the ratio of output current I2 to input current I1. That is the ratio of output current by input current. That is why it is called as current gain. Here V2 is considered to be short circuited. That is why it is called as short circuit forward current gain. Let I1 is equal to 0. That is port 1 is open circuited. From equation 1, we have V1 is equal to H12 V2 because the term H11 I1 is considered to be 0. Therefore, H12 is the ratio of V1 by V2 at I1 is equal to 0. The parameter H12 is called open circuit reverse transfer voltage gain. It is also unitless quantity because the parameter H12 is the ratio of input voltage to output voltage. Generally, voltage gain is considered to be output voltage by input voltage, but here H12 is equal to V1 by V2. That is why it is represented as reverse transfer voltage gain. It is from equation 2, we have I2 is equal to H22 V2 because the term H21 I1 is considered to be 0. Therefore, H22 is equal to I2 by V2 at I1 is equal to 0. The unit of H22 is mho. The parameter H22 is called open circuit output admittance because H22 is the ratio of output current to output voltage. That is why it is called as admittance. All the above parameters are having different units such as ohm for short circuit input impedance and mho for open circuit output admittance. Short circuit forward transfer current gain and open circuit reverse transfer voltage gain has no units. That is why H parameters are also called as hybrid parameters. Here two parameters are having units and other two parameters having no units. The equivalent circuit of a two-port network in terms of hybrid parameters satisfying equations 1 and 2 is shown in figure A. Equation 1 is V1, that is input voltage, is equal to H11 I1 plus H12 V2. Equation 2 is I2, that is output current I2 is equal to H21 I1 plus H22 V2. The above two equations are represented in terms of a equivalent network of a two-port network in terms of H parameter.